Assalamu alaikum. My registration number is 151150. In DSP lectures, lecture number 23 आज हम करेंगे. The subject will learn about transfer functions and some more examples of to clear Z transform. To understand some about the Z transform, we will do the example. This x of n is equal to minus a of n u of minus n minus n. This is basically an anti-causal system. Anti-causal system is that which possesses also previous values. The thing which is being to be remembered here is for alpha of n u of n, its Z transform will be 1 over 1 minus alpha of Z of inverse, and region of convergence will be Z greater than alpha. So we come to this example and solve it. First of all, we write the formula of Z transform, which is written here. And since this is an anti-causal system, we can expand this formula in such a way. And for proving to solution, we add and subtract 1 in relation A, as in this relation A we add and subtract 1 to get the solution, basically 1 minus 1, and this by solving this we come to this x of z is equal to 1 minus n summation of n is power 0 n of 0 to infinity a of minus 1 z n power n. So for this expression we can write, since this is obtained from infinite geometric series expression we have written in previous lecture, 1 over 1 minus a of minus 1 z. So by taking LCM and solving it, we obtain this solution 1 over 1 minus alpha of z inverse. So in Z transform we can write it inverse Z transform, we can write it z over z minus a. Z basically number of zeros, and these are in the denominator representing a number of poles. So the region of convergence will be entire in the region in the circle. So what is transfer function? We come to the transfer function. Transfer function is output over input, the relation. So we come to the example to understand it. Example says that here is a pole which is at a distance of 0.8 from the origin, and 0 is located at the origin. We have the expression, since we have already I have described here that inverse Z transform we can write the expression is z over z minus a. So by taking consideration into this form, z over z minus 8, so we can find frequency response formula, which is basically pi over big pi. This pi means length vector of zeros, and this says length vector of poles. So by observing this diagram, means since this is located at 0.8 from the origin, this pole, and for 0, pi by 2, pi, and 3 pi by 2, we get these values. This is basically frequency response of that. Now we plot these values as we obtained from this formula. So by plotting these, we have plotted this type of graph, and this type of graph says that this is low pass filter which passes basically low frequencies and rejects high frequencies. Student, this is all about lecture number 23. So if any queries you can comment. Thank you.